All right. Yeah, this thing is working. So, I have some news in Calc 3. Okay, so, damn it, let me provide a little context. Okay, so, let's pull up OneNote here. Actually, let's try something else. OneNote. Let's try that monitor. Oh wow, okay, so that just works the exact same. Okay, so display settings. Let's make this one my main display. And then Wacom or Wacom Center. Mapping. Okay, perfect. So I've struggled in math about 4 times. There are 4 different things that I would say counted as a struggle in math. Let me switch the way this is working. Okay. Okay, yeah, y'all can see that. So, the first was, actually no, there are about 5 times. There were 5 times I ever struggled in math. So first was middle school. There's a lot of stuff that I don't really want to get into, but it wasn't really because of the difficulty of the math. It was more self-esteem along with a bunch of other things. By far the hardest thing about middle school was I was no longer the smartest kid in the room. Or no, not even the smartest. I was. It was the grades. Like, I was no longer the kid that got the highest grades on everything, because there were kids that were like actually like smart like me, but that didn't have ADHD and didn't miss stupid stuff. Right. So I'd get like a 95, another kid would get a 96, and I'd be like, oh, well, I don't know what I am. And because I built my entire personality on being the smartest, I didn't know. I'm like, who am I? You know what I mean? And then I was bullied and stuff, and I built a PC in order to play video games to make friends, and it just ended up like being an escape so I could like isolate more. Like, middle school was a rough time. But middle school was rough all around, so that doesn't really count. So the first time it was actually math that was the tricky part, was trig. And most of these fit into 2 main categories. Actually, let me make a Venn diagram. I'm terrible at drawing circles. Okay, so this one we'll call memory, intuition. So we have memory, intuition, and then both. So the first time that I really struggled was trig. You have to memorize a lot of different things, a lot of different identities as it relates to trig, and because my memory was so bad, I'd always derive them on the test. Like, we'd be given a test or a worksheet or whatever, and on the very front of the page in like the margins or whatever, like, I'd just write down sine squared plus cosine squared, or no, sine squared of theta plus cosine squared of theta equals 1. And then from that, I'd derive tangent and secant, and then the double angle and then the squared properties. Like, it just required a lot of memory. It required either memory or time to derive things, and I didn't have either. So that's why trig was hard. The second time heavily math related subject was hard, was physics. Now, physics is tricky because physics requires experience. Physics requires intuition. With a lot of math related things, if you have a basic understanding of what's going on, you can derive it. And you can derive really your understanding of those things. Like, I didn't know the sums that added up that made sine and cosine, right? We had to know that for calc. And I knew that x to the n over n factorial, I'm not sure if it's 0 to infinity. Yeah, it is 0 to infinity, equals e to the x. I knew that, and I knew that e to the I theta equals sine of theta, or no, cosine of theta plus I sine of theta. I'm not writing out the entire thing. I knew that, and from that I was able to actually multiply that out and get the part that equals I sine of theta and then cosine of theta. You can just do things like that. And physics, though, you have to have practice, because when you're trying to apply things to the real world, you have to know what to apply and where to apply it. In order to know what to apply, though, you have to have a lot of experience with applying things, and correctly so. So I struggled with physics very, very, very much until the AP exam. I studied for 8 to 12 hours a day for, I think it was 4 days straight. No, hold on. Friday, Saturday, Sunday, Monday, Tuesday. 5 days straight, I studied 8 to 12 hours a day. Bare minimum, that's a 40-hour work week. At maximum, that's a work week and a half. So, yeah. That's how I resolved that. I literally just got 50 hours of practice in 5 days prior to the AP exam. Now, the hardest of them all, by far, so far, what by far so far, has been integration. But like at the difficult integration. I don't really have a better word for it, but it's where you'd have a binomial over a trinomial, or you'd have like a variable and then the variable plus 3 times the square root of the variable minus 7. Just like obnoxiously difficult shit. Because you have to have so much integration experience, and I know it's probably pissing some people off. I'm going to put dt because normally he gives us vector problems instead of just like 3 separate integrals or 3 separate integration problems. But like, I don't know, like it's just so hard learning how to do integrals. Hold on. Let me pull up like project 12. This is just music like in the background. Yeah, background music while recording. All right, perfect. Hello? Is that working? Is that loud? I hope that's not loud. All right, yeah, that should sound good. But yeah, integration, I'm gonna put this in like Calc 3 integration. Calc 3 integration. It's very, very difficult for me. Yeah, I don't even really know. So the first thing I'm gonna do is actually see if I remember like my trig. So we're gonna do derivatives. Sine is cosine. Yeah, I'll write in the theta, I guess, too. Sine of theta goes to cosine of theta goes to negative sine of theta, and then tangent of theta, that's sine over cosine. So we have sine, cosine, that's 1 over sine squared, so that's cosecant squared. Right? No, that's secant squared because it's over cosine squared. Secant squared theta. And then the derivative of fuck, what's next? Oh yeah. Cosecant of theta. This one's like, so 0 minus cosine, right? Yeah, minus, yeah, cosine over sine squared. So that's negative cotangent theta, and then cosecant theta. And then secant of theta is just, I believe, secant theta tangent theta. Let me check that. So cosine theta. That's just tangent theta, secant theta. A really good way to do it is envision it in your head with just C is cosine, S is sine, and then you have 0 C minus 1 S prime over S squared. Or no, over C squared. And then that just equals negative. Or yeah, negative, so that's positive. We're gonna ignore that. And then S over C is tangent. So then we have tangent times 1 over cosine, which is secant. And that's what I like to call the Jackson method. And then cotangent of theta is just, I believe it's cosecant squared, negative cosecant squared theta. Yeah, negative sine minus negative cosecant squared theta. So that's done. Now we have the antiderivatives. So sine of theta is just negative cosine of theta, because we're going backwards. Like if we integrated negative sine of theta, that's just negative integral sine of theta, which is cosine of theta. So if we took off that, then the sign would change, and then that's negative cosine of theta. Then we have cosine of theta is just sine, and then tangent of theta. Now this is what I like to call the Build-A-Bear method. I just came up with that name as I said it. So we have tangent of theta, right? I'm gonna write the d theta, trust me, just give me a sec. So we want, let me delete this entire thing. What we want is something in the form of the derivative of u over u times du. That is hella easy to solve, because then it's just ln of the absolute value of u plus c. So we need something that we can multiply tangent by. So we need to pick something in the bottom, and tangent times that is the thing's derivative on the top. So here we can see secant, its derivative is tangent times secant. So one factor is tangent of theta, and the other factor is secant of theta. Okay, and then we have damn, what else is there, bro? I think that's just it, honestly. So yeah, let's multiply this by secant of theta over secant of theta, because this is technically 1. This is the same thing. just erase that part. Okay. Then we have d theta equals, and then obviously this is tan theta secant theta over secant theta d theta equals natural log secant of theta plus c. And then that's how we get that tan of theta is ln I forgot to write all the plus c's. And then cosecant of theta. The cosecant and the secant of theta, I must admit, are a tad trickier. I'm gonna move all of this over here. And I'm gonna make it smaller too. Okay, perfect. Now let's run this back with cosecant of theta. So integral cosecant of theta times what? So we need something with cosecant, and then this has cosecant in it. So this right here has cotangent and cosecant in it. And then cotangent has negative cosecant squared. So let's multiply this by let's do cotangent of theta minus cosecant theta. Now that thing's derivative is negative cotangent theta cosecant theta negative cosecant squared theta. Ooh. Yeah, cotangent of theta minus cosecant of theta d theta, and then that just equals cosecant theta cotangent theta minus cosecant squared theta. Damn, I don't even know for real. What's in the bottom? Oh yeah. Damn, let's actually switch it up. Let's do cosecant of theta minus cotangent of theta. Cosecant of theta minus cotangent of theta. Such secant. I should have fixed this shit up. cosecant squared theta minus cotangent of theta cosecant of theta, and then d theta. So you can just see we're multiplying it in. And then here, the derivative of this, right, negative cotangent is positive cosecant squared, just switching the sign. And then the derivative for cosecant squared is negative cotangent of theta times cosecant of theta. So we have the same thing again, the derivative over the main function. So let me stack these on top of each other, actually. Point eraser. I feel like the Khan Academy guy, but like worse. I feel like mine's less interactive. And then here we have the natural log of cosecant theta minus cotangent theta plus c. And then for secant of theta, we just do secant of theta. I'm gonna speed run this one. Something really like easy that we can just pick, because everything is positive. Secant is 1 over cosine, right? So 0 minus cosine prime, so yeah, okay. Secant of theta plus, let's just do tangent of theta. Tangent of theta such that we get secant squared theta plus tan theta secant theta d theta. So the tangent, the derivative of that gives us this. Keep fucking this shit up. FML, bro. Actually FML. And then stroke eraser. So then we just get natural log of secant of theta plus tangent of theta plus c. And then for cotangent of theta, we get, move all these shits over. Like how with the original tangent, we only had to pick one. Cotangent has a tendency to behave similarly. So let's try that. Cotangent theta times cosecant theta cosecant theta cosecant theta d theta, and that equals negative. We're gonna add a negative in there. Negative cotangent theta cosecant theta over cosecant theta d theta, which equals ln, or negative ln, negative natural log of cosecant theta plus c. Perfect. So that's all of regular trig. Wow, that took a little minute. Now hyperbolic trig. Oh, that's not all of regular trig. What am I talking about? So now for the integrals, this part is going to be I'm just gonna remember cosecant minus cotangent, because you always minus with like the cotangents and the cosecants, and then the regular secants and the regular tangents, you don't do that. That's how I'm gonna remember this. So derivatives, we remember sine to cosine. I'm not gonna write the theta. Cosine to negative sine, tangent to secant squared, cosecant to negative cosecant, cotangent, secant to secant, tangent, and then cotangent to negative cosecant squared. Yeah, and then for the antiderivatives, sine goes to negative cosine, cosine goes to sine, tangent goes to the natural log of secant plus c. Cosecant is the natural log of cosecant minus cotangent plus c. And I remember because we list cosecant first when we do shit like this. And that's how I remember that's what I was talking about earlier. And then secant goes to natural log of secant plus tangent plus c, and then tangent goes to the natural log of cosecant, negative natural log of cosecant plus c. Let's see how we did. Okay, so got them all right. Now I'm gonna try and remember substitutions. So I don't really know. Let's try this. I know this one. 1 over a squared plus t squared dt, 1 over a arc tangent t over a plus c. I'm 99% sure that's correct. And then we have this, it's like 1 over root 1. See, I don't know this one. I don't know this one. Let's try U. Damn, bro, I genuinely don't know. I mean, I suppose if it's like a squared minus u squared, no, let's write that as t squared dt. We could just get that out of there and just rewrite that as one over and then a times, which we can then just take out of the integral, but I didn't write enough room. Oh, I guess I did. And then that's 1 minus t over a squared dt. And I don't know what that is, if I'm gonna be honest. Let's try and set that equal to something. Let's set u equals t over a equals arc sine of theta. Sine of u equals theta. Cosine of u du equals d theta. Damn. Sine of u equals theta. 1 minus cosine squared of u equals theta. Du equals oh wait, no, because we're trying to make that. Silly me, that was stupid. 1 minus sine squared of u du equals d theta. I fucked that shit up. I should have been writing it differently. This shit should have been sine of theta. I'm gonna set this theta d theta equals d u. That's what the variables. That's what the variable should be. U equals sine. So we have d theta equals du over 1 minus sine squared of theta, which is just equal u squared. Damn. I get it. So if we have this, we can just convert it to this d theta. So, okay. This is really how, okay. I just completely like understood how trig subs worked, which is crazy because I feel like I knew this before and I definitely should have known it before, but it's like now like I get it, which doesn't make sense because I think I had this breakthrough like another stream. Yeah, that's weird. That's trippy. Anyway, so we have an integral in this form. 1 over 1 minus, let's call it u squared, and then we have du. We can replace this entire red thing with d theta. So let's just write the arrow. And then we can just write d theta, which just equals theta. And because of the substitution right here, we know that that equals that. U equals sine of theta. So u equals sine of theta. So arc sine of u equals theta. And then we have arc sine of u. Makes perfect sense. Like complete fucking sense. Let's see if we can get the secant one, because I know there's a secant one in here somewhere. Okay, let's say u equals secant of theta. Arc secant of theta, or no, arc secant of u equals theta. So we have yeah, u equals secant of theta. Let's say the damn, u equals secant of theta. The derivative of secant is secant plus tangent, natural log of secant plus tangent. Right. Yeah. Yeah, so ignore this section here. This is just BS. Wait, what the hell am I talking about? That's secant theta times tan of theta. I was thinking of the antiderivative. Tan theta d theta. And then what is that? So sine squared plus cosine squared equals 1. So then we have tangent squared plus 1 equals secant squared. So u equals secant squared. And then tangent squared equals secant squared minus 1. So equals u squared minus 1, because u equals secant of theta. Du equals, I'm not going to write the du equals, I'm just going to, secant of theta is u, so that's u times just tangent equals u squared minus 1. So then we have u, and then that's useful. D theta. So if we have an integral in the form of like 1 over u squared minus 1, that'd be pretty lit. Okay, so my IG was hacked. One of my buddies actually went to the link on Twitter. You know how they like send out like a screenshot? It's like Elon Musk or Mr. Beast is like, oh, I'm starting a crypto or whatever. I don't like the actual rug pulls rich people do, but like people pretending that, yo, this rich person's starting a crypto coin. One of my friends actually did it, and he signed up for like Plinko or whatever. Super funny. Yeah, no, that guy's awesome. Yeah, dude. Yeah, honestly, I'm trying to turn down the music by like a reasonable amount. When you scroll on the mouse wheel on FL Studio, it'll turn it down by marginal amounts, by like 1.7 or like 1.1 or whatever. So like when I land on a nice round number, normally like 2 or 3 decibels, I normally keep it at that, and we just landed on -2, so I'm keeping it at like -2. So that's how we get arcsecant of u. I wonder if there's no, arc cosecant doesn't work. What about cotangent, I wonder? Arc cotangent of u equals theta. So let u equal cotangent of theta. Du equals secant. No, it was like negative cosecant squared theta. I'm fairly sure. See up here, oh, we didn't even do our regular arctangent, so we're just raw dogging this one. So how do we write u in terms of cotangent thetas? Okay, so let's see here. Tangent of theta, that's sine, and then plus 1 equals secant squared of theta. So cotangent squared, because we're doing 1 over like the entire thing. So let's do a negative tangent squared minus 1 equals negative cosecant squared theta, or equals negative secant squared theta. And then we do 1 over the whole thing. So 1 over negative t squared minus 1 equals negative cosecant squared theta. Okay, that's retarded. Okay, so negative that's dumb, bro. D theta equals negative d theta equals let's do 1 over, now let's do, damn it, d theta over negative t squared minus 1. And then u equals cotangent. See, this is the tricky part, getting this written in like cotangent form. Okay, so we have secant squared damn, bro, fuck. I mean, we could switch it over. Negative t squared minus 1 equals, or negative tangent squared equals wait, what? What the hell? Oh my god. Yo, I'm dumb. Actually dumb. So we have sine squared plus cosine squared equals 1. And we need cotangent, so we need to divide by sine. So we have 1 plus cotangent squared equals 1 over sine squared, which is secant, cosecant squared. -1 minus cotangent squared equals negative cosecant squared equals -1 minus cotangent squared d theta equals -1 minus u squared d theta. So we just have essentially negative tangent. That was a huge letdown. So if we have u times root u squared minus 1, we use secant. And then if we have 1 minus u, yeah. And then, yeah, so those are the important integrals. We're about an hour in. Now let's do hyperbolics. So cosine squared minus sine squared equals 1. Yeah, so let's do derivatives. So for derivatives, they're all positive. And then the reciprocals are all negatives. Like if we go up here, we can see there's a sign change with sine. Like sine's the odd one out, and then or cosine to negative sine, and then secant to a secant and tangent. They don't follow what the rest of their group is doing, but here it's all uniform. So cosine goes to sine, sine goes to cosine, and then tangent. That was the hyperbolic tangent function. I'm gonna have to derive all of these like right now because I haven't memorized any of them. Hyperbolic tangent function. I don't know what the fuck that is. Let's take a wild guess. Let's assume it's still sine over cosine. Or make sure to add the h's. So we have sine over cosine. So we have sine A all over hyperbolic cosine squared. So we have essentially cosine minus sine, which is 1 over the hyperbolic cosine function squared. So we have secant hyperbolic secant squared. And then cosecant, because we're just going to go in that order. Hyperbolic cosecant. Pretend these are in opposite order. Thank you. Hyperbolic cosecant goes to, I don't even know what that goes to. If I think really hard, I might come to it. It's just like 1 over sine, right? So we have 0 because the derivative of 1 is 0. We have negative it's 1 over sine, so we have 0 times sine minus 1 times cosine. And then over sine h squared, which gives us negative cotangent h cosecant h, and then secant of h gives us, and then the reason this is negative is because normally it'd be 0 minus 1 times cosine prime, but the hyperbolic cosine function doesn't sign change when you take its derivative, and that's why it's still secant h tangent h, and then cotangent h is negative cosecant h squared. For the antiderivatives, I'm unsure. Let's do an integral. First, let's do a tangent. Integral. Oh wait, no, I have to write A for antiderivatives. A. Sine goes to cosine. Sine of a hyperbolic sine goes to hyperbolic cosine. Hyperbolic cosine goes to hyperbolic sine. And then that's really like the elementary antiderivatives we need to know in order to do the rest of this. So integrating tangent, the hyperbolic tangent function, let's multiply it. I don't even know what by. Secant. Let's do t dt equals and then all over secant, hyperbolic secant dt, which gives us negative natural log and then probably a similar thing H. All right, that's perfect. I don't even really know what to do from here. Secant of H. I don't know. Secant of H times T plus C. Oh, what? Oh my gosh, I have to do the rest of them. So we have cosecant. This time, damn it, how do I do this? Oh my god, I keep circling the wrong one. Not even on accident either, like it's like my brain is just not. Yeah, we can just put that there for now. So let's do cosecant. Actually, no, let's do cotangent first. That one should be easy. So if we follow the same steps, cotangent H, T, let's do cosecant H, secant H. I'm just writing these out so there's like space, and then cotangent H. So if we do cotangent H to T times cosecant HT, cosecant HT, it's just negative cotangent HT, cosecant HT over cosecant HT. So then that gives us the negative natural log of cosecant of the hyperbolic cosecant function of T plus C. Cosecant H T plus C. So let's do secant first. No, let's do cosecant. Secant. What should we multiply by? Let's do tangent. No. I don't know. That's rough, actually. If we had tangent in the bottom, we need secant on the top. So let's do secant on the top and then tangent. And then in order to accommodate this secant, we would then need to add a secant and then add a tangent. Plus secant of H. Does that make sense? No, because you have to subtract secant and then tangent. Damn it. Let's try subtracting tangent because there is no sign change. Tangent of H. So the derivative of this would be negative secant h squared, and then the derivative of this would be secant h tan h. Tan h minus secant h. This is rough. Let's try tangent minus secant. There's gotta be a way, dude. Cos if we did tan minus secant multiplied by secant, we would get secant minus sec squared, but that's impossible. Minus secant squared, so that's just times secant. And then if we took its derivative, the derivative would be secant squared, and then minus secant So, okay, so if we just do -1 and then do tangent minus secant, secant ht dt we can rewrite we can rewrite that as negative integral, and then we have secant squared t minus hyperbolic secant ht tan ht, and then tan ht minus secant ht. Oh wait, but we flipped the sign. So this is, yeah, tangent. Wait, what? I'm just hitting redo or undo hella. What did I do wrong? Okay, so So what the direct derivative of this is negative secant h tan h plus secant h tan h. See, this is why I don't know how to do this. Oh, you know what we could do? We could do a fucking u sub 1 over sine, or yeah, 1 for, let's just do cosecant first. So we have 1, now let's just do secant first. Secant ht dt 1 over cos t dt and that equals sine squared plus 1 equals 1 over sine squared I think it's t plus 1. I bet. So based on that, okay, let's say let u I think I just did the opposite of what I wanted. Wait, u equals sine h of t squared. So that's technically just u squared plus 1 equals dt. So let's rework this. So we're gonna let sine h, or rather hyperbolic sine of t equal u. So then it's in that form, and then we're gonna let what's a Greek letter? What's a cool Greek letter? Rho. Rho's a cool Greek letter. No, but it's kind of hard to draw. What's a Greek letter that's easy to draw? Alpha? Gamma? No. Omega? No. Greek alphabet. There's ETA. I like ETA.
If I look up something sketchy.
Why is Carter PCs playing? Boy, what are we doing? No, I don't want to join Roblox, bro. Damn. Okay, so we're gonna use ETA. Sine HT equals U. Okay, so so yeah, we're gonna rewrite this with U's. We're gonna let U equals sine H squared of T. Or U equals sine H of T. Damn, bro. I'm genuinely unsure as to how I should approach this. Like, what the fuck do I do? Okay, so tangent. So we have cos squared minus 1 equals sine squared. Thus, secant. Right. Let's divide everything by cosine squared. Or no. So sine squared plus 1 secant H squared equals that plus 1. 1 over that plus 1. 1 over sine H squared plus 1. So we're gonna let U equals sine H of T, but I'm gonna cross this shit out. I was mistaken. I wasn't actually mistaken. I was just like, that was too early. So we have 1 over U plus 1. 1 over 1 over it's 1 over u squared plus 1. I wonder if that will give us like arctangent, or no, like that will give us arctangent. But like I want to use hyperbolics, so secant equals tangent squared plus 1. Secant equals tangent, no, secant squared. Where the fuck is that, dude? I'm so serious. Where's the secant? I'm trying to figure out like what I should replace. Okay, so when I have an like a regular integral in that form, I can use that. If I have u equals tan ht, we have du equals secant squared secant h squared t dt. Yeah. Now, how do we write secant squared in terms of tangent? So tangent is sine over cosine. So we have hyperbolic cosine squared minus hyperbolic sine squared equals 1. So if we divide all of it by cosine squared, we get 1 minus tangent squared equals secant, I'm gonna write the little h's, h squared, so we have equals 1 minus tan h squared t dt. Not too shabby. Now let's try secant. U equals secant, or hyperbolic secant of t du equals, what is the derivative of secant, of the hyperbolic secant function? So it's 1 over cosine, so 0, and then that's reciprocal, so it's negative. I'm pretty sure it's just negative secant ht tan ht and then dt. I have other homework I need to do, I just realized. Well, the least we could do is finish this. Negative is secant ht tan ht dt. So if that's the relation between secant and tangent, we have u equals secant. So the square root of 1 minus secant h squared t equals no, that's tangent. Damn, bruh. So that's 1 minus secant a squared t equals tan a squared. So I was right, but for the wrong reasons. And then remove the square. I'm not quite sure why I put that there. So we have d equals negative secant t 1 minus secant ht dt equals negative u 1 minus u squared dt. Okay, so the hyperbolics are actually mad useful, because like for tangent, so for sine and cosine we get this. For tangent and secant, yeah, this is what we get for tangent. We get 1 minus that instead of 1 plus that. And then for secant, we get 1 minus u instead of u minus 1. Or negative u times the square root. So up here, what was that? U squared minus 1 minus u. Like, that's fire. What the fuck? And then for regular arc sine, yeah. I think we just have to use regular tangent, I'm gonna be honest. Yeah, I think we have to use tangent squared plus 1. Or, yeah, arc tangent. So we have arc tangent of u plus c. And then u is sine h of d. T. All right, let's go through my modules for English. Okay, I can't find anything on our presentation. What the fuck? I'm looking here, bro, and it's like actually like nothing. Like, what? All right, we are back. I don't know where the announcement was. Assignments tab. Let's check this. Okay, I'm presenting on the 24th. That's relatively soon. Let's get this presentation done. Narrative multimodal assignment. I want to open this in a new window. I don't want this leaked. Okay, it says I didn't do something that I did. Oh my god, this was literally auto-saved from yesterday. I submitted it, I swear. Week 2 discussion of they say, I say exercises. All right, now let's open that again. So I just submitted it. Okay, yeah, it's actually submitted. It's actually in there. And this, I don't believe I did. Okay. Alright, what is this? Answer questions you're provided here on the sheet to receive credit. You will turn in these responses to assignment tab in Canvas. It will be presenting in front of the class for approximately 5 to 10 minutes, either in a live pre-recorded presentation of yourself. Or show us a digital montage of your work. Is there like a rubric? Let's see this, bro. Okay, so I can definitely make this in a 5 to 10 minute presentation based on this, bro. I'm gonna be honest, I'm trying to find the battery for a DSLR. Finally found the DSLR camera's battery. So yeah. God damn, I don't want to USB. Mini HDMI. Mom.